Okay, welcome back. What I want to look at is Level 3 NVQ Diploma in Installing Electrotechnical Systems and Equipment. Sitting Girls 2357 or 5357 now, I believe that it has since been changed to. Okay. Now, understanding the principles of planning and selection for the installation of electrotechnical equipment and systems in buildings, structures, and the environment. Now you'll find that this is the EAL reference number for the same course element. Okay, unit 3 or 4, this is Sitting Girls. Okay, now outcome 1, understand the characteristics and application of consumer supply systems. So that's what we're going to be looking at, consumer supply systems, and session 1, consumer supply systems. Okay, now let me just go back, make sure that we can get all of that in. Now I'm going to go for this frame by frame, basically to ensure that everyone can understand it. And remember, you can pause the video, extract the information, and make it your own. Do some additional research. Okay. So recapping, unit 3 or 4, session 1, consumer supply systems. Okay. Outcome 1, understand the characteristics and application of consumer supply systems. Okay, let's move on a little bit forward. Now here we have unit 3 or 4. Unit aim. This unit is designed to enable you to understand the principles associated with planning the installation of electrotechnical equipment and systems in buildings, structures, and the environment, and the selection of material, components, and equipment. And these are your learning outcomes. There are 4 learning outcomes to this unit. Understand the characteristics and application of consumer supply systems. Understand the principles of internal and external earthing arrangement for electrical installation for buildings, structures, and the environment. Now, item 2 brings to mind the specification in regards to the IE regs in regards to electric power supply for your charging electrical vehicles. Now, the problem is in situation where the earthing is being applied. Now, just for the power supply system in regards to electrical charging, there is a view to apply a TT system, that is a applied earthing at that point for the supply system down to ground using TT earthing. So it means that you'll be putting in a spike rod into the ground bonded to the equipment, or bringing in a earthing from the mains supply to your electrical charger. Now, that is still up for debate from what I can understand, but check the IE regs first before you do anything, because that is probably due to change or have amendments to itself made. But from my experience at this point in time, for me, I would apply a TT system plus the supply earth, and that's what I would go with at this point in time. Okay, but check the IE regs for the correct procedure. Look and read the information that comes with the unit. Okay, and here we have understand the principles of selecting cables and circuit protection devices. Understand the principles and procedures for selecting wiring systems, equipment, and enclosures. Okay, let me just go back, make sure we can get that all in. Now we're going fully, and I will pan to the right a little bit so we can get it in and it can be seen. Okay, now pan out. Okay, make sure everybody can see that. cells. Okay. Okay. Now I'm going to be doing this frame by frame. Okay. I'm not going to make it one long process because I need to be sure that you understand this and you can apply this for your own. Okay. Now here we have learning outcomes for this session, and the student will be able to gain an understanding of the arrangement for consumer supply systems. Okay. I'm just going to this a little bit closer. Okay. And come back. Okay. Now here we have, let me pan out for a bit, make sure I get everything in frame. Okay. Here we have an electrical grid consists of generating plants, transmission lines, transformers. The electrical grid has three distinct operations, and this is where I am reading from. Okay. And you can see here how this principle is applied. And I will get close into that for a little bit, but let's get into the text first. Okay. The electric power station where it is generated then stepped up to a higher voltage. It is then connected to the transmission network. The transmission network moves the power until it reaches the required substation. The substation is where the power will be stepped down in voltage from a transmission level voltage to a distribution level voltage. Let's pull out a bit. Okay. As it exits the substation, it enters the distribution wiring. Okay. And this is where I am here. Okay. Finally, upon arrival at the required location, the power is stepped down again from the distribution voltage to the required voltages. Okay. And this is where I am here now. Okay. Now let's just go back to the picture itself and show you, get a little close-up of this if we can. Okay. Extra high voltage. Okay. Then we're stepping down. Okay. And we again come down to a voltage to supply our houses, factories, and so forth, farms, and so forth. We now have a number of things producing power. Like before, we used to only have nuclear power stations and coal-fired power stations. Now we have solar panels bringing power into the grid. We have wind farmers now coming bring power into the grid. We have wave power also being generated into the grid. Okay. Sorry about that. A moment. Excuse me a second. I'm just trying to get something sorted here. Oh, sorry about that. Okay. It was just distracting me. Okay. Okay, let me just get back a bit, make sure we have everything in view. Okay. 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 Come back a bit, and we have everything in view. Okay, just to make sure everyone can see everything. Okay. Thank you. Okay. Now here we having a look at assessment of general characteristics. Part 3 of BS 7671 is entitled Assessment of General Characteristics. It requires the designer of an electrical installation to assess the purpose of which the installation is intended to be used, its general structures and supplies. So 1. The external influences to which it is exposed, the compatibility of its equipment, its maintainability, recognized safety services, assessment for continuity of service. Regulations 301.1 refers. In this first part, we will consider the arrangement of live conductors and the type of earthing system. Section 312 refers. Okay. Now, these refers to the IEE regulations or IET, I should say as well. Okay, but we don't know how Brexit will affect the BS 7671 just yet. But we'll have to wait and see, won't we? Now, conductor arrangements. Now, what you're looking at here is it's important that you are able to recognize the numerous ways in which a supply of electrical energy might enter an installation. So this is your main local substation. Okay. Your transformer will be bonded to earth. The center of it will be bonded to earth. Okay. You have L1, L2, and L3. Okay. Now, these are your output to your domestic dwellings. So you will have a 230 volt supply in respect of live 1 to neutral. But be aware that if you are supplying a domestic installation, you take the first property of L1, you then take the second property of L2, and you then take the third property of L3. You will not take all dwellings off the same phase, because that will cause an overload and that will cause the cable to overheat itself, causing massive damage back to your local substation. Right now here they're simply showing you the domestic one-off, and you may have 400 volt supply coming to your commercial enterprise. I'll just call it commercial enterprise, okay? A medium-sized shop, okay? But you'll have three-phase and neutral. Yeah? Now here this schematic diagram shows the types of supply from a three-phase 4-wire supply system. Okay. The majority of electrical installations are either single-phase 2-wire AC or 3-phase 4-wire AC. Okay. Now here we have order of supply. You have the supply to an electrical installation follows a very simple order. Cutout, this is the main protection at the point of entry and protects the supply from the connected installation. Meter, this measures the energy used and is commonly the property of the distributor. Main switch, this is the main means of isolation and can be situated inside a consumer unit or be a separate item of equipment. Its job is to isolate the connected installation from the supply. Control. These are the fuses or circuit breakers that are used to break circuits down into their constituent parts and enable various circuits to be independently controlled. So your ring main circuit, your lighting circuit, your kitchen units, etc., etc., your shower unit, etc. Okay. Just make sure we pan out that we can get it all in. Okay. And here we have single phase 2-wire. Here the supply is taken into a supply intake unit, often called a cutout. Okay. And that would be your unit here. Okay. That contains a main fuse and a means of earthing. Okay. So the supply then passes through the meter arrangement and then to the consumer unit, which contains a means of isolation. The order is overcurrent protection, metering, isolation, distribution. Okay. Closing on that a bit so you can see it in full. Okay. And of course move that across. Okay. Move back. Okay. Okay, so, sorry about this. I'm just trying to get something sorted out here if I can. I'm hoping that I can get it into a frame that makes it more easy to understand. Let's see. Okay, let's leave that one there. Let's see how it goes. And here we have a single phase 2-wire system. Okay. Here's a supply taken into a supply intake unit, often called cutout again, that contains the main fuse and means of earthing. And again here you can see you have your live and neutral here, okay? And that's feeding your consumer unit. The order is overcurrent protection, metering, isolation, and distribution. Okay. And here we have two-phase 3-wire supply, okay, L1, L2, and we're feeding 2 distribution boards here, okay. One goes here, one goes here, okay. And the neutral will feed each of these in turn, okay. Live neutral cables, earthing, okay, and that would be your earthing block. Okay. I need to look at see if I can adjust the brightness on this somehow or the other, but let's see, make sure we can get it all done. Okay. Two-phase 3-wire, okay, supply, okay. Two phases supply a common distribution board. Okay, the distribution board will need to be arranged for 2 different phases. Okay, so you'll have your phase 1 would be in a bank, phase 2 would be your second bank. Okay. Okay. That's two phases 3-wire supply system. Now 3-phase 4-wire supply. These are your 3 phases here, and that's your neutral phase. But you'll find that one single phase goes through each meter, and so your distribution again would be 3 phases. Okay, plus neutral and earth. Again, there are at least two ways in which a 3-phase 4-wire supply might enter a property. The differences are related more to the nature of the metering than the way in which they distribute power. Now, in this first arrangement, the supply to the cutout is then fed through 3 single phase meters and then to the mains of isolation and distribution. Okay. Three-phase 4-wire supply system. Okay. In this second instance, a 3-phase meter is used to measure the amount of any electricity consumed. So you have a 3-phase meter instead. Okay. Instead of separate meters, where supplies to an installation are large. It may also be the case that the means of metering the supply are via current transformers, which then feed the meters. Current transformers will reduce current supply, preventing the meters having any particular problem in measuring the current or what is used. Or I should say, simply say power. There are other types of supply listed in part 3 of BS 671, including single phase 3-wire, 3-phase 3-wire, and DC supplies. So you'll need to look that up for yourselves as additionally and read information in regards to the IET regs or IEE regs. whichever the case may be, in due course. Multi-choice questions, don't need to do anything on that, okay? Now I'd like you to actually answer these questions, okay? All the information is in the text. Look back at the information, answer these questions, okay? Let me go in first, see if I can make sure I can get them all in, okay? And then pan out slowly. Alright. You should be able to get them in. Okay, overall. This corner of my look quite dark. I have no idea why that is. Peculiar. Okay. And you make sure you can see the question, so there's nothing just for you to say, well, we couldn't see the question, so we couldn't answer it. I don't want any excuses. Answer the questions. Okay, thank you. I think that will be us for now. Okay. I hope you will find this useful. Okay. 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 Thank you.